Hey everybody, this is Larry. This is me doing the weekly premium challenge. Hit the like button, hit subscribe button, join me on Discord. Let me know what you think about this one. Apparently I did it at some point recently. That is still in my cache, but yeah. Today we have 1055, shortest way to form string. Hit the like button, hit the subscribe button. I always said that, I don't know. A subsequence of a string is a new string that's formed by original string by deleting some, or can be none, of the characters without disturbing the relative position of the remaining characters. ACE is just okay. We have subsequence, okay. Given two strings, return the minimum number of subsequence of source such that the concatenation equals target. If the task is impossible, return -1. Alright, so I'm a little bit thirsty. I'm going to drink this a little bit while I kind of read the examples. I don't know what it's asking for yet, so. Okay, I see. So the negative. So the first thing I want to think about is that the -1 case, right? The -1 case. Oh, n is 1,000. That may be interesting. But the n to the 1 case, it only happens when the target contains a character that is not in source, right? The reason should be pretty obvious. Well, I mean, the reason is obvious that why that's true, but also the contrapositive is true, right? Which is also important. Is it contrapositive? Maybe I confused them. But which is that if the target does not contain any characters that's not in source, you can always construct them. And the proof is actually not that bad. It's just that you may not be able to do the minimum, but you just do it one character at a time, right? If you do one character at a time, you have the answer. So that allows us to kind of do a easy filter for this thing, which is that, yeah. So how do I write it? So okay, set of target is the characters, right? So needed is equal to this, something like that, and then half is equal to set of source, right? So for, I don't know, there's actually a one-liner here, but I just want to write it out. If x is not in half, then we return -1. I almost return false, but yeah, right? Can't do it. Otherwise, we can do it. Okay, so that I honestly at this point I don't have a great idea yet, but I think it's just it's just keeping track, if I have to guess, because everything is greedy, right? There's no choice, because you have to. The reason I say that is because you have to do the characters one character at a time, right? So there's really no choice. I mean, there is a choice. There's a choice between choosing a number or a character earlier in the source or later in the source, right? But you will never really choose one later given two similar ones because of just very basic exchange principle, right? Like, you know, you can only do better by looking at it earlier. So it's just like keeping track, and yeah. And the way that I would keep track then, it is just, yeah, we look at all the indexes, or we parse the source for all the indexes. But n is equal to 1,000. That seems a little bit low, but maybe I'm wrong. But it feels like I'm right, but it's very possible I'm wrong, to be frank. But in any case, I feel like that is enough though, right? Because why would greedy be not enough? But the only reason why I'm doubting greedy is because n is equal to 1,000, to be frank. But yeah, I don't know, I don't think so though, but yeah, let's see. So here maybe we have indexes, and I write this enough times for some reason, right? Which is that for index C and enumerate source, index C is of C, we append index, right? And then now, as I said, we just do greedy at a time, right? But the part about is just that, yeah, no, that's fine, right? So we just keep track of the current index and how many times we use sequences, right? So maybe used is equal to 0, right? So we return used, we want to return this, and then current index is equal to 0. So current index will keep track of the current index that we are in source because we want to go by it. And then now, yeah, for C and target, we just now look up index of C, right? We want to bisect, we want to binary search for it, and we want to binary search right maybe bisect search left, say. Maybe that's a little bit better. And actually that's not the syntax anyway, but it's bisect, not bisect left. We have the index of C, we have the current index, right? This is the current index in source. Here, this will give us the lookup index, maybe L index, right? Or C index for the character index, maybe that's better. Okay, so that's character for C index, right? And then index C's of C index. Well, there are only two things, right? One is that if C index is greater than or equal to the length of index of C, that means that we went over, right? It means that we went over, we had passed the new one. So that means that we have to, maybe this should always be 1. I don't think that was 0 anyway. But yeah, in here, if we went over, then we increment by 1. And then but we still have to find the number again. But it's just the first number, so we have indexes of C of 0. It's the number we consumed. So then the character after that, which is +1, is going to be the current index, right? And that's it. And then else, we just consume it by this thing that we looked up, which we don't have to wrap around, so we don't do the use +1 yet. So so yeah, current index is just you go to this +1 to move to the next character that we can. And I think that's it, right? I'm just honestly, the only reason why I'm a little bit surprised and honestly I didn't explain it this well because the n is equal the numbers being 1,000 really confused me. I thought maybe there's an n² solution that they're looking for, and there probably is an n² solution, but I thought maybe that's what they're looking for, and so that the linear solution isn't fast enough or something, which is why I'm a little bit, well, this isn't linear, but I'll go over it. But the reason why I was going so fast is honestly because I didn't think it was correct. Like, I wasn't too confident that I was correct, that I was like, well, let me get this out of the way just in case it's wrong. So I didn't want to like over explain a solution that may be wrong, if that makes sense. But yeah, overall, this is just a binary search on the thing, right? We know everything I said was pretty precise though, which is that for every character in target, you have no choice. For every character in target, you want to get the next character in source the next possible character in source, and this is what we keep track, right? We count the number of times we used, meaning that we wrapped around, have to start over. Current index is just the current index of the source that we are able to start searching from, and then we just binary search from the C. So I don't think there's anything that much more complexing about this. I think I always feel like there's a linear version of this, but some variation of this have linear and some don't. So like this setup. So I don't know if this is one of those. Nah, I don't know. But what's the complexity, right? But, well, here this is all of n space, because literally for each character we put an entry in there. Yeah, and then for each character in target T, say, it's gonna be log n, right? This is at most. If all the characters are the same, then it's gonna be log n. So that's the worst case. So this is gonna be m log n, and that's your complexity. What was the? I wonder what I did last time. I mean, I didn't look at it that deeply, and apparently I got it wrong once. How did I get it wrong once? I mean, I drew a lot of stuff. That's why. I don't know. Maybe maybe the video is better. This is some. So I guess I did do it in some linear time thing. Oh, I mean, I was thinking about this, but I wasn't sure that I'm. Well, this is the wrong answer one, so maybe that's why it's wrong. I was like, okay. I was like, I don't see how that could work. And I was like, oh, I forgot, that is the wrong answer. And then here, this is right. Okay, that's good, that's good. But as you can see, actually, I did make an improvement over that time, because I recognized that this is not possible. Oh, you don't need to binary search for this, because it's always going to be the first element, because you're in the first element. So last time I didn't do that. This time it seems like I did it okay. You know, without the drawing. Maybe watch that video for the drawing if you're not. But that's really it. I mean, maybe we drew it out, but the idea is that you have no choice, so you just have to try to find the next number or the next character. And yeah, that is all I have for this one. Let me know what you think. Thanks for watching. Have a great weekend, everybody. I hope I get some sleep. So yeah, stay good, stay healthy to your mental health. I'll see you all later and take care. Bye bye.